Good afternoon, grade 8. We are still in the activity part of the
Good
module.
afternoon, sir.
And later on, we'll be discussing about your third periodical tests, right? Let me clarify things over. Your tests will actually include Module 1 and Module 2 because this is third periodical, right? This is not mastery. So let's continue. This is your electron configuration, right? We are done discussing this one and you know already how to use this table. Are there any question with the electron configuration? Rabi? Yes?
No, sir.
Okay, let's continue. Electron configuration tells information about electrons in an atom. It tells how electrons are arranged in the subshells. Remember that we are actually predicting on the activities of these electrons. In addition, it identifies the valence electrons. Okay? The valence electrons is the electrons found in the subshells of the highest principal quantum number or the outermost shell. In Bisaya, sa pinakagawas, the outermost shell. Right? Knowledge of valence electron is important. Okay? The rule to determine the valence electron is simple for atoms belonging to S blocks or S block. Atoms with S subshells being filled up and the P block atoms with P subshells are being filled up. Atoms belonging to S and P blocks are called representative elements. Okay, the one we discussed um, the previous meeting. Okay, let me share my periodic table of elements. If you have question, please raise your hands. All right. So, where is the S and the P block? Okay. If this is your periodic table, the representative elements are found in 1, 2, 13, 14, 15, 16, 17, 18. Okay. Let me share with the blocking. Okay. We have actually blocks to consider. Blockings. Okay. Just give me a second. I'll be projecting now the blocks. Okay. Sure, where is the S and the P block? Okay, let me share my screen. This is the S and the P block. Can you see my shared screen now? Grade 8?
Yes,
Yes.
sir.
Okay. This is the S
Yes.
block. Okay. And this is the P block. Okay. Which contains now your representative element. Sure. How about the B block? Okay. Your periodic table is divided into two, okay, elements. The major, um, the major types of element. We have representative element, and the second one is the in the center is the transitional or transition elements. Okay, we will be focusing on the representative element from A1, from 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Right? This is for electron configuration only. Okay, because this um this transitional element or transition elements need another formula no in getting their what electron configuration. Okay, let's move forward. Okay, this is the table again. The S block, this one, and the P block are composed of what? representative element. At the center, the D block and the F block are composed of transition elements. Atoms where D subshell and F subshells are being filled up with the said belong to the D and F block, respectively. They are called transition elements or transitional elements. The rule to determine the valence electron does not work in transition elements. Yes, because we have different formula in getting those valence electrons. By the way, how can you know that this element has these valence electrons? Sure, what is really valence electrons? Okay, this is the electrons outside the valence shell or the outermost shell of an element. Like for example, let me share my screen. I'll be sharing the periodic table. Okay. Your valence electrons is actually in the groupings. Like for example, group 1A, diba? This is group 1A. So it has one valence electron. Group 2A has two valence electrons. Group 3B to 3A has three valence electrons and so on until it reaches what? 8A. Remember, we are considering only A. Okay? The representative elements. Okay. Like for example, sure, what is the representation of helium? Helium has complete valence shell. Kompleto siya. Okay? Complete valence electrons. So if you're going to look at the valence shell of or the outermost shell of helium or neon, let's have neon. Neon. Let me do the annotation. If you're going to look at the valence shell of neon, okay, it has 8 valence electrons in the outermost shell. So if this is the outermost shell, it has actually 8 valence electrons because neon is actually one of the noble gases. Okay, one of the noble gases. Okay, can you see my shared screen? Grade
Yes,
8?
sir.
Okay. So in this area here, this one, these are considered as the noble gases. How about helium, sir? Helium has only what? Has two valence electrons only. But it is considered as one of the noble gas. Okay? Helium has two. Supposed to be helium should be here. But because helium is a noble gas, it should be written here. Okay? Helium has only two valence electrons. Okay? The rest, like hydrogen, has one valence electron. Beryllium has two valence electrons. Boron has three valence electrons. Carbon has four valence electrons. Nitrogen has five valence electrons. Oxygen has six. Fluoride has seven. And again, the noble gases has eight valence electrons. Okay, this is actually the outside shell. Okay, question so far? Question so far? Grade 8?
None, sir.
No, sir.
Okay. Let's move forward. Refinement of electron configuration. Again, the quantum mechanical model of an atom, you learn that subshells or sublevels have orbitals like S is 1 because it can only hold up to 2 or maximum of 2 electrons. Okay? So, maximum of 2 electrons. Diba? So, I will annotate. I will let you see. Okay? In the S, it can only hold up to 2. Okay? Electrons maximum. In the P sublevels, it has only 3 orbitals because it can only hold up to 6 electrons, maximum of 6. The D sublevels or subshell can only hold up to how many? 10. That's why it's 5. Okay? F can hold up to 14. That's why it's 7. So, if this is the shell, if this is the orbital, this is the orbital for S. Okay? One up and one down arrow, it represents 2 electrons. Okay? The P can hold up to how many? 6. The maximum of 6, right? Electrons. Therefore, it has 3 orbitals. 1, 2, and 3. So, if you're going to look at the electron there, it looks like this one. 1, 2, 3, 4, 5, 6. So, the P subshell has 3 orbitals. 1, 2, 3. With 6, the maximum of 6 electrons. How about the D? The D orbital can contain up to 10 or maximum of 10 electrons. Therefore, it has 5 orbitals. Okay? Which contains your 10 electrons. Okay? By the way, the arrows there represent the electrons. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is why you have 5 orbitals. Because the D sublevel or subshell can only hold up to 10 electrons. How about the F subshell? For the F subshell, it can hold up to 14 electrons. Therefore, it has 7 orbitals, which contains 14 electrons. Okay? So 1, again, the arrow there represents, or it represents, the electrons in the orbital or inside the orbitals. Okay? So, your F subshell contains 7 orbitals with 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Am I making this clear? Grade 8?
Yes,
Yes,
sir.
sir.
Okay. By the way, how can you make notations in your, let's go back. How can you make notations with respect to the element? Like for example, let me share my screen again. Let's have the periodic table. So let's have the periodic table. Okay. How can you make, like for example, phosphorus? Now let's make the notation for phosphorus. Again, in writing notations with certain elements. Okay, this is basic. You should write first the symbol of the element, followed by, or look for, the second one is what? Your atomic number. So let's have this one. Let's have phosphorus, for example. Okay, phosphorus. So that the symbol for phosphorus is P, correct? Grade 8. Grade 8. Are you still with me?
Yes, sir.
Okay. Symbol for phosphorus is P. Okay. In the upper part is your atomic weight or atomic mass. So the atomic mass for phosphorus here in my periodic table is 30.97. Okay, do not round off. Again, do not round off. You consider the whole number. So let's have 30. Okay, the atomic mass or atomic weight of phosphorus is 30. And the atomic number, for phosphorus is, what is the atomic number of phosphorus? Atomic number of phosphorus? Anybody? Robbie?
15.
15. So it is 15. So that is actually the
15, sir.
15. Correct. That is actually what? The notation of the element. That is how we make notations of certain elements or element notation. Because in your major exam, you will be asked to make notations of certain elements. Okay? This is really basic. Let's continue. Do you have any questions so far? Anybody?
No, sir.
Okay, when
Sir?
electrons enter sublevel containing more than one orbital, they will spread out over the available orbitals with their spins in the same direction before they paired up with the opposite spin. Okay, this rule is known as the Yoon's rule or Yoon's rule of multiplicity, which was proposed by Frederick Yoons or Hans, a German physicist. So like for example, for the P subshell, let's have this one. Like for example, P, it can only hold up to how many? The maximum of 6 electrons. How about 3p5? Okay. P has 3 orbitals. Okay. And it contains 5 electrons. So, according to Hund's rule, before pairing up, they usually what? Spread out. So, let's spread out. 1, 2, 3 before pairing. So, let's pair up. Okay, 1, 2, 3, 4, 5. So, this is the correct spreading out of electrons based on Hund's rule. Let's continue. Just like this one. Okay? This is 1s2, 2s2, and 2p3. 1, 2, 3. So it actually spreads out before pairing. Electrons occupying the same orbital must have opposite spin. That's Pauli's exclusive principle. The magnetic properties can be predicted if you know the orbitals diagram. The presence of unpaired electrons gives rise to the paramagnetism. It is the property of substance to be attracted by a magnet. Diamagnetism refers to the property of substance to be repelled by magnet due to the presence of paired electrons. Okay, so let's move now to your exam. Okay, for your exam, test 1 is an identification. Test 1 is an identification. Okay, you're asked to identify what? Some terminologies. Test 2A is completing the table or filling up the missing data. This is pertaining to the number of protons, neutrons, and electrons, and even element notation. That is why we are discussing a while ago element notation. Test 2B is the electron configuration. You're asked to write the complete electron configuration of certain elements. Test 2C is an essay or analysis. You're asked to analyze its situation and answer in the space provided. Again, please study on getting the protons, neutrons, and electrons, and even element notation. Study also about electron configuration. You're doing that one. You will be doing a lot of that in your major exam. Okay? Do you have any questions so far? Questions so far? Grade 8?
None, sir.
Okay. Still, we have 6 minutes left. And what I want you to do now, since we still have time, let's make it double time. I want you to answer activity number 2 in your LMS. Open your LMS and go to activity number 2, which is atomic models and theories. Okay, again, let me share my screen. What I want you to do now is I want you to go to your LMS, okay, and go to activity number 2, answer activity number 2, which is atomic models and theories. I'll be expecting answers from you till the end of the day. Do you have any questions so far? Grade 8?
None, sir.
Okay. I think that will be all for today, class. Again, I'll be waiting for your answers till the end of the day. Have a nice day, grade 8. Goodbye.
Bye.